Hello friends and welcome to another tutorial on Geeks for Geeks. In this video, we are going to understand the program which prints sorted order of a given array that represents a binary search tree. First, let us take an example. For example, given an array 4, 2, 5, 1, 3, the function should print 1, 2, 3, 4 and 5. Now, let us see the algorithm. Let us also have a sample tree to test our algorithm. Let's assume that array is 4, 2, 5, 1, 3 and we pass array along with 0 and array size -1 to function print sorted. As start is not greater than end, we print the left subtree. So we pass the array start into 2 plus 1 that is equal to 1 and end to print sorted. Again, as start is not greater than end, we pass 1 into 2 plus 1 to start now. Again, since start is not greater than end, we pass 3 into 2 plus 1 that is equal to 7 to start. Now, as start is greater than end, we return to the previous call. Next, we print the element in the array at the index start, which is 3. So, 1 is printed. Now, we pass start into 2 plus 2 that is equal to 8. Again, as start is greater than end, we return to the previous call. Execution for start equal to 3 is over. Now, we resume execution for start equal to 1. So, we print element at index 1 in the array, which is 2. Now, we print the right subtree. So, we pass start equal to 1 into 2 plus 2 that is equal to 4 to the print sorted function. As start is not greater than end, we pass start into 2 plus 1 that is equal to 9. Now, as start is greater than end, we return to the previous call. Next, element at index 4, which is 3, is printed. Now, we pass start equal to start into 2 plus 2 that is equal to 10. Since start is greater than end, we return to the previous call. Execution for start equal to 1 is over. Now, we print the root which is at 0th index in the array. So, 4 is printed. Next, we call for the right child of 4 which is 5. So, start will be equal to 2. As start is not greater than end, we pass start equal to 5. Now, as start is greater than end, we return to the previous call. And we print element at index 2 which is 5. Next, we call for the right subtree of 5. So, we pass start equal to 6. As start is greater than end, we return to the previous call. Execution for nodes at index start equal to 2 and start equal to 0 is over, and we have the final output. Now, let us have a look at the time complexity of the program. This code will run in big O of n complexity. Here, n are the number of nodes in the binary search tree. With this, we come to an end of this tutorial. For any doubts or suggestions, please leave them in the comment section below. Thank you for watching.